Hello students, today we will discuss some important chemical reactions of carbon. And in the very first category, what the chemical reaction what we are going to deal, that's the combustion reaction. Basically, in short, this combustion reaction can also be defined as the burning of substance. So if any substance is burnt on the burning, and the burning always occurs in the presence of oxygen, like if I burn sulfur in the presence of oxygen, so as the product I get sulfur dioxide gas, and this burning of sulfur in the presence of oxygen can be termed as the combustion reaction. Now in place of sulfur, if I take phosphorus, a molecule of phosphorus when reacted with 5 molecules of oxygen, as a product we get phosphorus pentaoxide. And in this reaction again a phosphorus material is going to react with oxygen or it's going to burn. So this reaction can also be taken as the example of combustion reaction. In place of phosphorus, if I react nitrogen with oxygen, so nitrogen forms various kind of oxides when reacted with oxygen, such as one is nitrous oxide, second oxide that may be formed, that is nitric oxide, third time it may form nitrogen dioxide, dinitrogen tetraoxide or dinitrogen pentaoxide. If any of these oxide is formed by the reaction of nitrogen and oxygen, then this reaction can be termed as combustion reaction. But here, since we are going to study the reactions of carbon, so here we will only pay the attention on the reactions of carbon and its compounds with the oxygen, or the combustion reaction of carbon and its compound. If as an example I take carbon and react this with the oxygen, then as the product I may get carbon monoxide or carbon dioxide gas. It depends on the supply of oxygen. If oxygen is taken as the limited supply, then the product will be carbon monoxide, and as oxygen is taken in excess, so the final product will be carbon dioxide gas. In place of single carbon, if I take a carbon compound, like if I start with methane, so when methane is reacted with oxygen, as the product of combustion reaction, we may get carbon dioxide and a molecule of water. Now, if I talk about the utility of combustion reaction, then the very first utility is, since most of the combustion reactions are exothermic, and in case of carbon, the combustion reactions of carbon are exothermic in nature. Since combustion of carbon is exothermic in nature, this is the reason why we use carbon and its compound as a fuel. Such as if I talk about a common fuel that's known as natural gas, then the major component of this natural gas is methane. If I talk about that fuel that we deal in our daily life for the cooking purpose, we use the LPG gas. The main component of this LPG gas is again a carbon compound that's termed as butane. So since most of the carbon compounds, they burnt with oxygen, they react with oxygen, and the resultant reaction is exothermic in nature. So this resultant heat can be utilized for the purpose of cooking, for the purpose of driving vehicles, and this is the reason why we use carbon compound as the fuel. So if I am to write this reaction in a complete form, this reaction is exothermic in nature, and as the product we will get the energy in form of heat and light. And most of the combustion reactions are exothermic in nature. The exception of this is the formation of nitrogen oxide. The formation of nitrogen oxide is a combustion reaction, but this one is not exothermic in nature. This one is an example of endothermic reaction, and all other combustion reactions are exothermic in nature. The second utility of this combustion reaction is, if I am to check the nature of an unknown compound. If I am to check the nature of an unknown compound, if I am to find whether the given sample which I am provided with in laboratory is a saturated compound or an unsaturated compound, so by the combustion reaction we can have the knowledge that whether the given one is saturated or unsaturated. If on burning this sample burns with a smoky flame, So if the sample burns with a smoky or with a sooty flame or with a black color fumes flame, then by this observation we can judge that the given sample is an unsaturated compound. And since we are talking about carbon compound, so we may judge that the given sample is an unsaturated hydrocarbon. On the other hand, if this sample it burns with a clear flame, so if the sample burns with a clear flame, then this kind of observation proves that whether the given sample is saturated in nature. Now if we go for the reason behind this, that why the unsaturated compound it burns with a sooty flame while a saturated compound it burns with a clear flame, then since an unsaturated compound has high percentage of carbon, in the unsaturated compound the percentage of carbon as compared to saturated compound it is higher, and due to the high percentage of carbon, when it is burned in the presence of oxygen, some unburned carbon particles are left, and this is the reason that due to the presence of these unburned carbon particles the color of the flame seems to be black. On the other hand, if I talk about saturated compound, so these saturated compounds or saturated On the other hand, if we talk about the saturated compound, so these saturated compounds or saturated hydrocarbon, they have less percentage of carbon as compared to unsaturated hydrocarbons. And due to the presence of less percentage of carbon, whenever these are burnt in the excess of oxygen, all the carbon particles goes for the burning and the resultant product is carbon dioxide gas. And since there is no unburned carbon particle left, so the resultant flame color is it burns with a clear flame. On the other hand, however, if oxygen supply is limited, if we burn the organic material in the limited supply of oxygen, then in the limited supply of oxygen, whether this one is unsaturated or saturated compound, finally we get some unburned carbon particle which were not able to react with oxygen due to the limited supply of oxygen, and in the presence of limited supply of oxygen, all these unsaturated and saturated compound they burns with a sooty flame or they burns with a smoky flame. So this is the utility of combustion reaction. Now we will be dealing with the second kind of chemical reaction, that is substitution reaction. The second type of chemical reaction is substitution reaction. This substitution reaction is defined as the chemical reaction. This substitution reaction is defined as the reaction in which an atom or a group of atom is substituted or replaced by different atom or group of atoms. For example, if I react methane with chlorine and if this reaction is taken in the presence of diffuse sunlight or diffuse ultraviolet rays, then as the product we will get this one chlorine atom will replace one hydrogen atom, and as the product we will get a molecule which will be having 3 hydrogen atoms and 1 chlorine atom. This molecule is termed as chloromethane, and here the left 1 hydrogen and 1 chlorine will react to combine 1 molecule of hydrogen chloride. In this reaction, if I talk about that what's going on, so in this reaction the 4 hydrogen atoms of methane, out of these 4 the one is going to be replaced by 1 chlorine atom, and since an atom is going to be replaced by another one, so this kind of reaction can be taken as an example of substitution reaction. If I continue this substitution reaction with chlorine with this chloromethane, again if I react this with 1 molecule of chlorine in diffuse sunlight, then again 1 chlorine atom will again replace another hydrogen atom, and as the product we will be getting the molecule CH2Cl2 dichloromethane, and again a molecule of hydrogen chloride will be formed. By repeating this reaction again with chlorine in presence of ultraviolet light, again one hydrogen atom will be replaced, and finally we will be getting a molecule trichloromethane and a molecule of hydrogen chloride. Since this trichloromethane has one more replaceable hydrogen atom, so when it is reacted further with chlorine in the presence of ultraviolet light, finally we get a molecule with no any replaceable hydrogen atom, and all chlorine atoms are present with carbon atom. This molecule is termed as tetrachloromethane, or commonly this molecule or commercially this molecule is known as pyrene. In this reaction, the chlorine atom is continuously going to replace the hydrogen atom of this hydrocarbon. So this reaction can be taken as the example of substitution reaction. Another one, now if the same reaction with the same hydrocarbon molecule, methane, this time in place of chlorine, if I react this with bromine, again the same condition is required. This reaction will occur only in the presence of ultraviolet radiation, and in this condition, if initially I am going to take the excess of bromine, so in this condition these bromine atom will replace all the hydrogen atom, and finally we will be getting tetrabromomethane, and 4 molecules of hydrogen bromide will be formed. So all the halogens in presence of sunlight can replace the hydrogen atoms of hydrocarbon, and they can show the substitution reaction with hydrocarbon. In place of methane, if I take another hydrocarbon with more number of carbon atom, such as for the example if I react this with ethane. So when ethane is taken in presence of chlorine, all the hydrogen atoms will be replaced if I am taking chlorine in the excess of it, and finally we will be getting a molecule like CCl3 connected with a single bond. Again a CCl3 bond is there, and finally since 6 hydrogen atoms are going to be replaced, these will again react with chlorine atom, and as the byproduct we will be getting 6 molecules of hydrogen chloride. So all the saturated hydrocarbon, initially we have taken methane, that's also a saturated hydrocarbon, and again we have reacted with ethane, that's also an example of saturated hydrocarbon. So all the saturated hydrocarbon can show the substitution reaction, and this substitution reaction can be taken as the characteristic reaction of saturated hydrocarbons. Since as I have said that all the halogens can substitute the hydrogen atom of hydrocarbon, if I talk about the reactivity of these halogens, so out of these halogens, fluorine is the most reactive halogen, and which will show this substitution reaction very vigorously. In the case of chlorine, the reaction is less vigorous. In the case of bromine, the reaction is not so much vigorous, and in case of iodine, this reaction does not occur. So this reaction occurs with a difficulty. So this is the order of reactivity for the halogens of for this substitution reaction. Now we will be looking for the third kind of carbon chemical reaction, and that is the addition reaction. The third kind of carbon reaction that we are to see here is addition reaction. Addition reaction is basically a characteristic reaction of unsaturated compounds. And here we are talking about the hydrocarbons or the carbon compounds. So we may say that it's a characteristic reaction of unsaturated hydrocarbons. Addition reaction is basically defined as the reaction in which a reactant molecule is added to another reactant molecule to form a single product. So this reaction is taken For example, if I take a molecule of unsaturated hydrocarbon and we are taking the first member of unsaturated alkene, that is ethene. If ethene is reacted with a molecule of hydrogen, so now this hydrogen will destroy the unsaturation of this compound, and by the reaction of this hydrogen on ethene in the presence of nickel catalyst, we will be getting a molecule of saturated hydrocarbon, that is ethane. So in this reaction, a small molecule hydrogen is going to be added on an unsaturated compound to give a single product. So this reaction can be termed as addition reaction. And in this addition reaction, hydrogen is going to be added. So this kind of addition reaction can be termed as the hydrogenation reaction. This hydrogenation reaction is also used in the formation of vegetable ghee, such as for the formation of vegetable ghee, initially we take vegetable oil and when this vegetable oil to destroy the unsaturation it's reacted with hydrogen in the presence of catalyst nickel, and the temperature is also specific, that is 473 Kelvin. So by the reaction of this hydrogen on this vegetable oil, that's an unsaturated hydrocarbon, a saturated hydrocarbon is formed, and this saturated hydrocarbon is termed as vanaspati ghee, which is found in solid state. So this hydrogenation reaction is going to be used in the formation of vegetable ghee, that is a saturated hydrocarbon, and as the reactant we have used here a vegetable oil, that's an unsaturated hydrocarbon. Now in place of hydrogen, if we add any halogen on an unsaturated compound, so this kind of addition will be termed as halogenation reaction. As the halogen, we may use chlorine, bromine, iodine or any other halogen, such as at the initial I am going to react this unsaturated hydrocarbon with chlorine. So whenever this chlorine molecule is going to be added on this ethene molecule, finally we will be getting chloroethene, that is CH2Cl connected with a single bond to another CH2Cl. And in this reaction a chlorine is going to be added. So this reaction of halogenation can be termed as the chlorination reaction. In place of chlorination, when I use bromine, so this reaction has a specific use because this reaction can also be used to find the saturation or unsaturation of an unknown sample. If ethene is reacted with bromine, finally as the initial the product we have made, so the same product will be finding, and the molecule will be CH2Br connected with a CH2Br, that can be termed as dibromoethene. In this reaction, as the reactant for the bromine liquid we are taking, this bromine liquid has a specific color. This is a reddish brown color liquid, and whenever it's going to form a product, so here the bromine molecule is not there. Here the bromine molecule is dissociated into two bromine atoms that are going to link with another carbon atom. So in this condition, this solution is colorless. So now this specific observation is used to check whether the given sample is saturated or unsaturated. If bromine is reacted with an unknown sample, and by the reaction if the solution is going to be colorless, the initial reddish brown color of bromine is going to be disappear. So by this observation we can find a conclusion that in this sample there is a unsaturation present, and on this unsaturation when bromine is going to be react with, so by this reaction we are getting a colorless solution as a product. So in this condition we can find that the sample is unsaturated in nature. On the other hand, if I react bromine with a sample, and in this reaction if the solution remains as it is and the color of the bromine does not go for disappearance, in this reaction by this observation we can conclude that bromine is not going to react with this sample, since the color is same as it was in the initial. So if the sample is not going to react with this bromine, we can find the conclusion that the sample is saturated in nature, and that one will indicate the presence of a saturated hydrocarbon. The same addition reaction is also used to find the saturation or unsaturation of a compound, but now this time we use a different reactant. If a sample is reacting with a Bayer's reagent, that is 1% alkaline KMnO4, then this 1% alkaline KMnO4 solution is known as Bayer's reagent, and this Bayer's reagent is violet or dark pink in color. if the sample is going to show the addition reaction with this Bayer's reagent, by this addition reaction we can say that since the addition reaction is a characteristic reaction of an unsaturated compound, so now in this condition, on the other hand, if I have taken the sample and it's not going to show any reaction with this Bayer's reagent and the color is as it is, so by this observation we can conclude that the sample is not showing addition reaction with Bayer's reagent, and addition reaction is a specific reaction for unsaturated compound. So we may say that this compound is saturated in nature. So this is the utility of addition reaction.